Remember those old days of REST API when launching one REST API endpoint felt like launching a rocket? Yes, those old days I am talking about. Imagine you have just launched your first REST API and you are super excited to flex this in your friends. So, what you do? You hit a bar, call your friends up, and you are flexing your skills. Now, one of your friend who is overly enthusiastic. I know every group has that one friend, right? He wants to surprise you. So what he does is he writes a script which will generate traffic on your endpoint full night, thinking that you will be surprised and happy seeing this traffic. At least some part of it was true now, because you were surprised to see so much angry emails from your customers in the morning. Turns out your API wasn't ready for this party, right? Your real customers got blocked and your logs are exploded with so much traffic, right? So, congratulations, my friend. You have spent your first DOS attack caused by a friendship. Beautiful tragedy, right? This is 100% avoidable. So, how do we prevent this in future to happen, right? Only two words I would say: rate limiting. From having a daily quota on number of tweets that you can do to per minute API request quota that you have, rate limiters have been acting as a gatekeeper to modern web applications. But not all type of rate limiters are created equally. So in this video, I'll walk you through all different type of rate limiters available right now, starting from having bucket type of rate limiters to counters and also to log type of rate limiters and why they exist. So here is the deal. There are five essential type of rate limiters available in the market right now. First one being the token bucket rate limiter. Then is your leaky bucket, followed by fixed window counter and then sliding window log bucket. Last is sliding window counter rate limiter. No worries. These names would look fancy before we actually start and delving in into each one of them. So, in this video, I'll give answer few of the essential question about each one of these rate limiter. That is, how they work, when to use them, and why to choose one over the other rate limiter. We'll understand in what use case which rate limiter is best suited. So, grab a coffee with me or a beer, whatever keeps your system stable, and let's start the journey to understand the evolution of rate limiters today in our modern web space. Have you ever wondered why you are broke by end of every month? It's just not you. It's about science. And I would term that as token bucket mechanism. Imagine this, that you get your salary credited on first of every calendar month. That is your filling rate. That means when you will get your next salary credited. And then there is a maximum amount that is promised to you by the company. That is your bucket capacity. Now, at the start of every month, you feel rich and you start buying those expensive clothes and gifting those expensive clothes to your girlfriends as well, right? And then you also take them out for expensive dinners. By 15th or by 20th of the month, your card payment starts declining. That's when you start feeling broke, right? That is exactly what token bucket mechanism in rate limiter does. Now let's take this example out and understand this with a real world web application. Imagine that there is a bucket that gets filled with four tokens every minute, and the bucket can hold up to maximum four tokens. Any request that comes to my rate limiter, so any request basically has to pass through rate limiter. It's a gateway, right? So as soon as a request comes to my rate limiter, I would check if there is a available token in my bucket. If there is a available token, I'll pass this request along to reach my server. If I don't have any tokens, then the request is denied with an HTTP status code that is 429. And that means that too many requests have reached the server. This is how your token bucket mechanism works. This mechanism is also used by big players like Amazon. This model is great because it allows a burst of traffic without blowing them up in your backend, right? It blocks some traffic after your capacity is complete for that particular window, right? So, what are the benefits that this mechanism has? It is easy to implement, it is lightweight, and it is burst friendly. A burst of request can be accepted. Now, what are the cons of this? Because there are only two parameters, it's very hard to configure this in the right way. There is a limited edition Hot Wheel car dropping this week. You are visiting that website and trying to hit that buy button, and you always see this message sold out again. This is because the Hot Wheel factory has set a limit on number of orders that it will take for a month. Not because they have some grudges against you, it is because they can only process a set number of cars or prepare set number of cars for a day. That's exactly what leaky bucket algorithm is, where there is a queue where you put in all the requests that you can and you process each request at a fixed rate. The queue has a fixed size. That is the monthly the capacity that Hot Wheels have set. And then there is a fixed rate at which you keep processing those requests from that queue. If the queue is full, you will politely deny every other request that wants to enter your server. Now, here is a small challenge for you guys. Can you guess two parameters that can help configure this rate limiter for me? Yes, that's correct. That's the queue size and the rate at which you will process the request from the queue. Easy, right? But this fixed rate gives a very predictable rhythm, right? So now let's imagine this that your queue has a capacity of four users or four requests, and it processes one request per second. Now, if there are five requests that reaches your rate limiter, you would only accept the first four, queue them, and deny the fifth request. Now, these four requests, you will not pass them on to the server in that same burst of time. You will pass that to server one request at a time. Per second, you'll only pass one request to the server. So server is not overloaded when a burst of request is reached to the rate limiter or the API gateway, but you are able to process those bursts, yet your server keeps a rhythm of processing the request. In real world, this algorithm is being utilized by YouTube, Shopify, and many other APIs when they care about how fast they want to process the request. They don't care about the number of requests or the burst of request that comes in. They have a set rhythm of processing the request. That's when this algorithm is utilized. And now, meet that cousin limiter. If the token bucket is a wild child, impulsive and bursty, leaky bucket is that older cousin who likes to be calm, steady paced, does one thing at a time, gets overwhelmed if you try to push too much. I think you got the analogy now, right? So now let's understand what are some positives and negatives of this algorithm. So, this algorithm gives you a predictable and controllable outflow of request. It is memory efficient because there is a fixed size of queue that you will maintain. But on the contrary, the negatives are that a burst of traffic will be dropped. Because if you receive a burst of traffic which is more than your queue capacity, you will start dropping that, right? Then, not ideal for systems which have real-time processing. For example, your stock trading application. You cannot use this algorithm at your stock trading application. Now, coming up next is a fixed window counter mechanism. Spoiler, this mechanism is so simple that you can hack this mechanism by just arriving late or early in a particular window. Now, keeping that in mind, let's start understanding this algorithm in detail. So you just got promoted, right? Probably because you binge watched my videos or binge read my articles. Don't worry, I accept all credits in the comment section. So promotions are always attached with some additional responsibilities. In this one, your manager has given you an additional responsibility of taking 10 interviews every month. Let's imagine this scenario. Your interview scheduling team has started dumping the 10 interviews of January in last week of January. And then in the coming week of February, it has again given you 10 more interviews. Ideally, you cannot deny those requests because your manager has mentioned that in one particular calendar month, you can only do 10 interviews and you can deny any further request in that calendar month. So, ideally, this interview scheduling team has found a hack around and they have scheduled 20 interview, but in a time duration of 20 days, maybe you are overwhelmed and you cannot do anything because they have fulfilled the mechanism that the manager has suggested, right? Technically, this is what the fixed window counter mechanism look like, where you say that in a particular window, I will accept a particular number of requests. And as soon as that window is completed, the counter is reset to zero. Now, a fresh counter will start for next bucket. So again, there are only two things that you need to configure this rate limiter. That is, one is the limit, that is the limit of requests or the max number of requests that you can accept in a particular window. Then is the window size, the size of window in which you can accept that particular number of requests. Now, there are few positive sides to this mechanism are that it is dead simple to code. It is fast because it just has to reset some counter variable at end of every window, right? And works fine when your traffic is distributed evenly. The con of this mechanism is that if your traffic is not distributed evenly and you get burst of traffic at end and starting of the interval, you tend to serve more requests or probably at least double the number of requests that you just saw that we gave 20 interview in that window. So to solve this problem, we came up with another approach that was sliding window log mechanism. In the next section, stay along and we'll understand how the sliding window log mechanism is one of the best rate limiting algorithm in the world right now, and how it solves the problem of the counter rate limiter. Now imagine that you are applying to one of your dream company and the HR there has a bit of OCD. She wants to keep her inbox up to the mark, cleaned, and under control. Now, let's say, what does this HR do? As soon as she receives a resume, she would want only to keep resumes for 1 week. So, what she does is, as soon as a new resume arrives, she would clear off all the resumes that are older than 1 week. Then count the number of resumes that she has after removing all the old ones, and if that is under the limit, she would accept that resume. Otherwise, she would send a flyery denial email to you saying that sorry to inform you and we'll keep in touch. Welcome to the world of sliding window log rate limiting. It logs at the timestamp every time a new request comes in, clears off all the old requests outside that particular window. And that window is decided based on the newest request that we have just received, the timestamp of the newest request. After clearing off all the old records or all the old logs, it would watch and count the number of logs that it has now. If that is under the limit, it would accept that request. Otherwise, that request is denied, mentioning that your request has been throttled and the request status code is 429. So on the screen, you can also see a short demo that I have prepared where there is a request that came at exactly 1 o'clock 1 second. It was allowed. We have added that request time log in the logs, right? Then there is second request that came at 1 p.m. at exactly 1 p.m. 50th second. This request is also accepted. So let's say we are only maintaining two requests for a duration of 1 minute. Then there is third request that came at exactly 1 minute and 10 seconds. Now, when this request came in, I checked my log and I found that there is an that is older than 1 minute. So I removed that time log from my timestamp from my logs and add this timestamp. By this time, I see that I still have the limit of two requests per minute under control. So this request is also passed. Now, after 5 seconds, exactly after 5 seconds, I receive another request. I add that timestamp to my log, that is 1 minute and 15 seconds to my log. I validate if there is some older request. No, there isn't any. I check the size of my log now. My size should be under two logs messages, which is not true. So this request is denied access. We'll throttle this request, but we'll still maintain this timestamp in my logs. And that's the only drawback this mechanism has. Real world use case would be in systems where every millisecond matters, like your banking APIs, your trading platforms, or any analytics dashboards. The key takeaway for this mechanism is that if precision is very important for you, then only go to fixed window log mechanism. Okay, with that in mind, let's jump to the new and the last rate limiter that we have in the market. That is sliding window counter. You know that one friend who is not obsessed on details of how things are done, but still gets the job done. That's sliding window counter for you guys. It says no need to log every request. Let's just split the time window into some counts and keep counting the request in a particular chunk. So what it does is it breaks your window into sub windows, tracks the count per slice of that window, that small subsection of the window, and then adds up to decide if the request is should pass or not. It's like you in the gym, you don't care about who enters the gym exactly when. The only thing that you care about is it should not be overcrowded at any given point in time. So this one is simple, but yet the most efficient mechanism that you will ever use would be fixed window log mechanism, because it will never fail or never allow excess requests to get into your system. Okay, folks, the moment of truth. Who is your rate limiting partner? On your screen, you can see a detailed comparison of each rate limiter based on different parameters. But I'll make that simple for you guys. If you need bursts of traffic to be handled, your go-to would be token bucket mechanism. If you need a constant flow of requests to your server, then you would use the leaky bucket mechanism. If you want it easy, then fixed window counter mechanism is your go-to mechanism. But if you need precision and you really don't want extra requests to come in, then sliding window log mechanism is your buddy. But if you want a balance between the last two, that is the fixed window counter and sliding window log, then sliding window counter is your rate limiter. So from just listing those five type of rate limiters to rocking that understanding on each of them and when to use them, you have made so far. And you should appreciate yourself if you've reached this part of the video. Now, we started with a simple beer and broke the API. And now we can talk that what is a token bucket mechanism, or what is a sliding window, what is sliding window log mechanism. And we have got our hands dirty to understand what type of rate limiter you would choose in which scenario. Now, this isn't just a theory. You would want to implement this, and that's exactly what I'll do in my next video. So stay tuned And make sure that you share this video with your friends who want to understand or who should understand rate limiters in depth. In the next video, I'll break this down and implement each of these rate limiters in Golang.